I'd like to model for the people who come back in that we're on, since we're moving. So let's go.
That makes sense or not?
Yeah.
Who uses number talks in their classroom?
Number talks.
Who uses number talks?
Be proud. Raise your hand.
A number talk is a very specific thing.
Yeah.
Do tell.
Cool. Let's talk about it.
Number talks. Do you use them?
So we're talking about using number talks. A few people use them. A lot of people don't. Here's the concept. They're short, like less than 10 minutes. If it's more than 10 minutes, it's like a mini lesson.
Yeah.
It could be like a daily-ish or like somewhat common routine. Usually it's some sort of a mental computation, and its purpose is to help students develop computational fluency. Generally it will happen alongside ongoing math curriculum, but doesn't necessarily need to be related to what you're going to do. It sparked in my classroom a concept called Mental Math Monday, where we do a number talk every Monday, so not daily, but a regular thing that we could expect. I've also heard teachers use Throwback Thursday,
And
which
Fun
is like
Friday.
and what?
Fun Friday.
Fun Friday. So Throwback Thursday, if you don't know, is like a social media thing. You like, here's a picture of me when I was little. Teachers use it to spiral. So Monday I might do mental math activity related to what's happening that week, and then Thursday I might do something from last unit or beginning of the year or whatever. So those are some general features of a number talk. We're going to do a number talk, which means I'm going to ask you to do some mental math. So take them. I know we're jotting this down.
Okay.
That's chill. We're all going to share these slides with you, but I'd be writing it down if I was in your shoes too. That's just the kind of person. So I'm going to give you a problem. So when you're done jotting down notes, go ahead and you can just tilt your screen down a little bit. You don't need to close it all the way so it won't sleep. Sometimes I call this 30 and 30. So in 30 seconds, all of our screens are at 30 degrees. Might be 30 and 30, everybody, because we're doing laptop stuff, and then they know they got 30 seconds to get to like that. The first time we do it, we have to be really analyze the degree of the screen, and then after that, it's chill.
And
yeah, so no pencils.
No
We're doing this totally mental math. When you have an answer, you're gonna give me a secret thumb. If you got a thumb up, because I'm gonna give a lot of wait time, I want you to think about a different way to get to the answer you just got. So you can give 2 different ways to get the same answer. You're gonna add a finger. All right, so this indicates to me that I've got 2 different ways to tell you how I got to an answer. And if you can think of a third way, you have a third finger. And like, if you're crazy, then by the end you might be like this. You guys ready?
Ready. So answer is thumbs up.
Answer,
Right here.
I got an answer. I can tell you how I got an answer, thumbs up. I can tell you 2 ways to get the answers, 2 fingers, 3 ways, 4 ways, 5 ways, 10 ways.
And then spear fingers.
One way doesn't work in this.
And the third,
No, right.
the third finger is an additional finger, not just the
one
third
finger.
finger for
Right,
6th graders.
right.
Oh, yes.
Okay, you guys ready? Here's our Throwback Thursday problem. And I usually wait a really long time. Like in class, like I'm totally down to just let it be awkwardly silent for an awkward amount of time. My students. So the other thing is when you put a thumb up, you're saying like, I have a way and I want you to ask me to tell you what the way is. Sorry. And the secret thumb is so that it's to not distract. If your thumb goes up really quick, if it's out here, that's going to bum someone out. And if it's here, that person might not know this. That's the secret thumb. If you get it wrong, it's okay. Like mental math is hard. So even if you're an adult and you get it wrong, like if you're you right now and you get it wrong, it's totally cool. So I didn't tell you what the thumb meant. You're going to tell me how you did it. Lighting, could you tell us you've got one way to get 60% of 240.
I started with 50%. 50% of 240 is 120. And then I know 10% is 24. So I just added 120 plus 24, and it's 120.
How many people did it that way? Oh, well, you're in good company. That's how I did it too, the first time. Then I stopped thinking and started paying attention. Cool. Alright, who has a different way to get it? If you had a second way that's different from that way, go ahead and just put your hand high so I can see who you are. Cool. Alex, how'd you get it?
I changed 60% to become 6 over 10, and then reduce that to 3 over 5, and then divided 240 by 5, and then, what was that? That was 48, and then multiplied that by 48 times 3. Should be.
So we got two different people who got the same results. Instead of just asking for a different way to get the same answer, I might have asked if anyone got a different answer. Right? I'm not giving clues as to rightness or wrongness. If someone sees 144 and that's what they got, they're going to be more likely to volunteer to give the second way. So I've sort of, and then we've sort of subtly indicated rightness or wrongness. So if you want to keep that out of the loop, you might just ask for who got a different answer, tell us how you got that answer. Someone tell us why Alex divided by 5 and then multiplied by 3. What's up with that?
She made it how they're related to the ratio. They're 3. 144 is right. 3 parts or 48. Should figure out what was 3 parts of what was 5 parts. What would go into 245 times. So then she knew that, because 6 over 10 is rich and it's 3 to 5, so she simplified it. It's relationship 6 and 10, 100%.
I genuinely don't understand. Could
No.
someone help me understand? I mean.
Yeah, no, sorry.
Yeah. No, it's not no problem. I mean, just that. Yeah.
So she changed it to 6 over 10 so she doesn't like working with percents, and then she simplified the fraction, 3 over 5.
Okay.
So then her new whole now is 5 rather than 10. So then she's seeing how many 5 goes into 240. And then so there's if 5 goes into 240 48 times. And then since it's 3 parts out of 5, she has to figure out how many times 3 times 48 is. The individual parts.
Yeah.
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 I just like complicated.
Is it?
I do that too.
So she's setting it up as proportions to seeing what you need to multiply by 5 to get 240.
Right.
So she's doing
So
it backwards.
3 out of 5 is what out of 240?
Yeah.
That's what she's working on?
Yeah. Except she did it in reverse
I feel-
rather than.
Right. I feel better about that now. Thank you for helping. Alex came up with a realization about something that might have been a little easier. And have a thought, like, kind of sticking true to her method, what might have been a different step that would have been more simple? Yeah.
I don't know if this answers your question,
It's okay.
but this was one method that I did, but instead of thinking like 240 divided by 5, the reason I was thinking, okay, so this is kind of a tangent, but my method was looking at 10% of 240 and then multiplying it by 6. So another method was to look at 3/5. Okay, so that's 3 1/5. So how much is 1/5? That's 240 divided by 5, which is 48, and then 48 times the 3/5 is the
I like
Or you
the
could
5 out of it.
But I'm just a dude trying to do math. Like, I just like that. Yeah, cool, thanks. So you helped me with the y divided by 5. You said there are 3 1/5s. So you divide by 5, that's the 1/5. I need 3 of those, so I multiply it by 3. That helped me understand y divided by 5 and then multiply by 3. But you started with a new
method.
new
Yeah, I'm
method
sorry,
of
that's
logic.
why
Can
I
someone
thought of
help us fill in the gaps there? I'm so pumped that you got us started on a bounce to like someone help us finish this new line of logic. And we'll go from there. Apple.
I did it so 240, but then the next step was different. So 10% of 240, we're teaching students, just move it over one, so that's 24. And then 24 times 6 doesn't sound like a very easy number to do in your head, so I just did 20 times 6. And then I added on 4 times 6.
Which gets us what? Let's keep that. Let's finish.
Okay,
Let's get
so
to.
120, because that's easy mental math, plus 24.
Ooh. And I see a connection now between that method and our original
Yeah.
method. So you guys look for that connection. Someone verbalize that connection. With more.
More than a
No, that's an approved. Yeah. Yes.
I would do 50 and then just take away 6. So 5 times 50 is 250 minus your 3 times 2 that you've added is 6. So 50 is 3 times 50 is 250. I'm sorry, 5 times 50 is 250. But I'm short 2. 50 minus 48 is 2. 3 times 2 times 3 is 6. So 2. So I'm sorry. Yeah. So 50 is. Okay. So I got to the 50s, right? Instead of 48.
Yeah.
I'm doing 50s. 5 times 50 is 250.
So
So 3 times 50 is 150.
you're back at the second method.
Yeah.
Oh, okay.
Oh.
Using 50s instead of 48s, because you
I get
said
it.
using
Oh.
distributing. And then I just subtracted my 6. My 3 times 2 is 6. So
So instead of
150 minus
doing-
6 is 144.
Instead of doing 3 times 48, right? 48 is kind of like 50.
Yeah.
So if I had 5 50s instead of 5 48s, I'd have 250.
Right.
But I added 2 to each of those 5 pieces, so I added 10 too much.
6.
6 too much, because 3 times 50 is 150.
Yeah, so it's 246. So
Oh, I
take
see.
away 6 from the 250.
50,
Oh,
144.
sure.
Yeah.
Okay. What? Yes, Sherry.
So looking at the 6 over 10 gave me the idea that it was a tape diagram.
Nice.
So to break 240 into a compatible number would be 24 times 10. So if you have 24 times 10, so you have 10 squares or 10 rectangles, with each containing 24. Then you say, okay, what is 60% of that tape diagram? So then you take the 6 and you multiply it by 24, and you get 144.
Awesome. Thanks to everyone who shared. We're going to stop the number talk here because we went on any longer, it'd be too long. Even though there might be really rich discussion to be had, trust me, your students don't want to have it anymore. You had them for that 10 minutes. Right? If you had them for that 10 minutes.
So you only do one problem in your class?
Oh, yeah. Well, it depends.
Okay.
In this case, one problem, if I had this rich of response for my students, one problem is totally enough. I even have a second problem. If you don't, we're not going to do it. Even though I was so excited to ask you this question, it doesn't matter. I'll save it for next Monday. Or next Thursday.
Does that 10-minute include the wait time when you're waiting for a session?
That's a good question. I don't know. I think the person who coined this whole idea actually said 10 to 15. So yes, or no. So no. Wait time plus 10 minutes of discussion. Could be. All right. So that's number talk. This actually is related to the curriculum we're learning. So this was going to be my next question, which is a really sneaky question to ask. We're not going to do it right now, but if you want to think about it, it's the calculation I just asked you, or 240% of 60, which has a greater value. Think about it. We're going to keep moving. Yeah. More on number talks. I had, I don't know where it came from, but when I was in FAME, I recorded this link so that I could find out more about number talks. I'm so organized that I still have all that information, so I pulled it up to share with you.
Don't worry, this will be shared with you guys.
And this will be shared with
You don't need
you.
to scramble the.
Did you find it already?
Yeah, it already looked.
Did you just Google number talks and this popped up?
Awesome.
Maybe that's where I found it.
Yeah.
I don't know where it came from. I just know that I had it. And what's another resource in your back pocket? You might get to it, you may not.